Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Great, let's take a look at our M&Ms for our homework for 2.1.5. This particular M&M is telling you about the commutative property of both addition and multiplication. And basically this property is just telling you that you can rearrange the order of the terms in your expressions and it will not change the value when you are adding them together. Now you may recall, when I was doing the previous homework and in lessons, I think I might have mentioned this in lessons, but definitely in the homework in the past, if you've got like 2 minus 3, commutative property doesn't work. 2 minus 3 is negative 1, and 3 minus 2 is positive 1. But the moment we change this to 2 plus a negative 3, now we can rearrange the order. So commutative property, this ability to rearrange the order of your terms, applies to addition, and it also happens to work with multiplication. If you take 3 times 5, that's the same as 5 times 3. It does not work for division. So if you took 6 divided by 2, you're going to get 3 for an answer. But if you took 2 divided by 6, you would not get 3. You would get 1/3. And that's where, if we were to change this to 6 divided by 2 is the same as 6 times 1/2. Now you can rearrange the order by changing the division problem to an equivalent multiplication problem by multiplying times the reciprocal of this number 2. So now 6 times 1/2 is the same as 1/2 times 6. They're both equal to 3. So commutative properties work for addition and multiplication, but there are some little tweaks that we can do for subtraction and division to turn them into addition and multiplication problems so that we can utilize commutative property. All right, simplify the following expressions by combining like terms. Again, we'll highlight, you got an x, you got another x, you got a third x, and there's a negative x. So 1, 2, 3, 4 x's minus that 1x gives us 3 x's. And then the other terms, there's nothing to combine with those. So any order you want to write these is fine. I always write the variable term that has the variable raised to the highest power first, then the next power, and then finally I finish it up with the constant term and the back end. This is not a big deal in 8th grade, but when you get into higher levels in 9th and 10th grade, there's going to be a reason why you want to have the highest degree term listed first and then go in descending order. And by highest degree, I mean the one with the greatest exponent. Okay, so same idea here. Identify the terms that have the same variable parts and be aware of the fact that that's a positive x squared, but this is a negative 13x. So you're going to add 8 to negative 13. Oh, wait, do we have, and we got this one too. So really we got 18 plus negative 13 is positive 5. And then for our x terms, you got 3x and negative 25x, and then another x that's a negative. So really it's 3x plus a negative 26x, which is negative 23x. Okay, I'll let you look at the others and you decide if you want to get in touch with me and ask me a question. All right, so when writing an expression for part A, problem number 42, I guess that's on a previous homework, Ricardo wrote 2x minus 3 minus x plus 1, while Francine wrote negative 3 plus 2x minus x plus 1. Is this okay? And the answer is yes, because basically what you're doing is you're doing commutative property, but you would have to, think of this as 2x plus a negative 3. Then when you reverse them, you've got your negative 3 first and then the 2x second, and then you don't have to worry about having parentheses there, because we only really put the parentheses when we're adding a negative so that you don't accidentally blend the plus sign with the negative sign of the number. So that's when we would put that. That's why it's sometimes easier to just write it as 2x minus 3, because you don't need to worry about a parentheses if you're subtracting. But when you're adding a negative, you'll want to have the parentheses. But essentially, this is commutative property, and it works just fine for this problem. 2 lines at right represent the growing profits of company A and B. So the x-axis is time in years, and the y-axis is profit. And this is the independent variable because the number of years affects the profit of the company. Okay, so it looks like both companies' profits are increasing over time. Line A, company A, started off with more profits than company B. But because company B is making more money per year, it's a steeper line. So eventually they intersect at a point where their profits are exactly the same after the same number of years. But then beyond that, now company B has greater profits because they're making more profits per year. That's why it's a steeper line. Okay, so sketch the graph on your paper. If company A started out with more profit than company B, determine which line represents A and which one represents B. So this one was A because it started off with more, and then this one was B because it started off with less. And how many years will both of them have the same profit? Well, there you are. This is year number 3. And then being able to determine what that profit is, sometimes you see it's lined up perfectly, sometimes it's not. What is this? Counting by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. So it looks like after 3 years, they would both have $60,000 approximately, or maybe 65, depending on exactly where that goes, somewhere there. So you're estimating. That's why I put this little symbol that means about 65,000, because it's hard to tell on the graph the specific number. If we had the rules for each one of those companies, I could tell you the exact answer, but we don't. We just have the graphs. Did I cover everything there? Companies B's profits are growing more quickly, so that line is steeper. Yes. All right, evaluating expressions. When you know the value of x, you plug it in and you go through the order of operations. So 4.3 times -6 gives you -25.8, and then you add 2 to that to make it -23.8. Here, we're going to plug in x, so 9 minus 3 is 6, and 6 squared is 36. Here, we're going to plug in -2, so -10 minus 4 is -14. And here we plug in 3.5 minus 2 is 1.5. Those were way too easy. Got to work a little harder making these more challenging. All right, and then our last problem. When baking cupcakes for his class of 21 students, Sammy needed 2 eggs. So that's your ratio, 2 eggs for 21 people. This is not a problem I would want to figure out a unit rate for. Seems like it'd be a little bit like how many eggs per person would be a horrible decimal number. I suppose you could flip it and say each egg takes care of 10.5 people. That could work okay. But we'll just do proportional reasoning. And I think in this case, does 21 go into 336? I'm not really sure. 336 divided by 21 is 16. Okay, so if we multiply this times 16 and this times 16, there's your giant 1, and that's how you get 32 eggs are needed if you're going to be serving cupcakes to 336 people. And I believe that does it for today. All right, so let's get started on today's lesson. Take care. Bye.
Hey, feeling good.